Today we're doing lesson 3-6, analyzing lines of fit. We're going to be using technology. Please put your name on your paper and the date and what period you are in. For the definition of a linear regression, that is a method used to calculate the line of best fit for your data. For example 1, it says model using Desmos, but we're actually going to use a TI-84 graphing calculator. And they're asking us, what is the equation of the line of best fit for the data in your table? So you're going to use this calculator, and at the bottom of the calculator is the on button. And after you turn it on, this will be your screen. We want to put the data that's in this table into our calculator. And so you will do that using the stats button, which is right here, stat. And it says edit. So we're gonna choose edit. We want to clear the data. So you're gonna arrow up and over to where it says L1, and you're going to push clear. Then you're going to push enter, which is at the bottom of your calculator. Down here, push enter. So that will clear the list. Do the same thing to list 2, clear, enter. We will start in list 1, and we're going to put the data from the table. So 1, arrow down, or you can push enter, 2, arrow down, 5, 8, 9, and 17. Then you're going to arrow over. After you put in 17, push enter so that you can arrow over to list 2. In list 2, we're going to type in 30, 55, 75, 120, 145, and 250. Your data should line up. So we should have 2 blanks right here at the bottom of our lists. And the next thing that we're going to do, you could graph it, but that's not what we're going to do. You will click the stat button again, right here, stat, and you will go to calculate this time. So see how we were on edit before and we just pushed enter to edit? Arrow over to calculate. Then you can arrow down to 4, which is linear regression, and that is all set up for you. You just need to come down to calculate. Now, it told me the line of best fit, but it didn't tell me something that we're going to need later. So what I need to do is, this gives us the equation, right? So like y equals ax plus b. That should be pretty familiar to you, except that for the a, we usually use the letter m for slope. So the equation of the line is y equals 13.5, we'll round it to 6, x plus our b, which is 17 we'll round it to 5, 9. All right, in your calculator, just so we're set up for the next problem, I want you to go to the catalog. So this is a couple steps. You see the blue button here, it says second, and then we have down here 0, second catalog. So the blue button, then press 0. We need to go all the way down to the D's. So instead of arrowing all the way down, which you can do, there's a shortcut. The D is right here, the matrix. So we just push that button and it goes down to the D's, right? So you just push this button, it gets us down to the D's. What we are looking for is diagnostic on. So right here in our list, so when I arrowed all the way down, or I went to I pushed the D's, took me into the D's in my catalog. Diagnostic on, once you're arrowed on that, push enter, and then it brings it to your calculating screen, push enter again, and then it's done. And we just need to save it like that for our next problem. Before we get on to that, I would like you to do the try it. So you're going to follow the same exact procedures. You're going to go to Stat. You're going to edit the list, and we're going to need to clear that list. So arrow up, clear, and then enter, and it clears the list. So in your list, put in these numbers that are in this table for list 1 and list 2. Then remember, you'll go to Stat, you calculate, and we want the linear regression. So choice 4, and it brings it up. I don't have any data, but it'll bring it up for you in your calculate screen. So go ahead and do that, try it now. For the correlation coefficient, that's represented by R, and it is a number between -1 and 1. It indicates the direction and strength of the linear relationship. So if it's closer to -1, then it's a strong negative correlation, and if it's close to 1, it's a strong positive. So strong negative if it's close to 1, and strong positive if it's close to +1. Bivariate data is a set of data that uses two variables. And we should know that because bi means two. So bivariate would mean two variables. Example 2. What does the correlation coefficient reveal about the quantities in a bivariate data set? So do you remember I told you to change the catalog, or in the catalog, to have diagnostic on? I'm going to write those steps down right here because that's what's going to give you this screen. So what you need is to turn the catalog on. So in the catalog, which is this button down here, the 0, you push second 0, and that will take you to the catalog. From the catalog, you want to go to the D's, and in the D's, you want to go to diagnostic on. And then you just push enter, and then you push enter again, and it'll turn it on so that you get the R values, which are right here. And what do those R values mean? Well, up here, that's the correlation coefficient. So R's are our correlation coefficient. If the R is close to 1, then, like right here, that number 0.984 is close to 1, so there is a strong positive correlation. And you can see that because all of the dots are very close to being on this line. So there is a strong positive correlation with that line of best fit. And the calculator gives us the line of best fit. When R is close to 0, the data doesn't seem to have a correlation. So it's like all over the place. So this is a weak or no correlation. When R is close to -1, see how our line is going down and all of the dots are close to it? That is close to -1, negative 0.995. So that's our correlation coefficient. Then it has a strong negative correlation. Even though it's negative, there's still a correlation. Go ahead and do these try it problems, and then we'll pause the video so you can get those done. Residual. A residual is the difference between the y value of a data point and the corresponding y value from the line of best fit. And so you can see that we have the actual value here, and then the line of best fit would be right here. And so here is the actual point, but if it were on the line, it would be here. So the way that we figure out the residual is that we take the actual y value minus the predicted y value. And a residual plot shows, which is right here, a residual plot shows how well a linear model fits the data set. If residuals are randomly distributed on either side of the x-axis and clustered close to the x-axis, then the linear model is likely a good fit. We are now on the next page, and we are going to ignore some of this because it's teacher notes. This is student enrollment at Blue Sky Flight School over 8 years. So we're looking at student enrollment over 8 years. All right, so we have the 0 year up to year 7, and we're going to take this out as well. What we're going to do is we're just going to practice putting this into our calculator to find the residual. So turn your calculator on, go to Stat, Edit, and in List 1, if you haven't already, clear it, and clear List 2, and type in this data. Up to 7, so from 0 to 7, and then go to arrow over to List 2, and they had the first year 1,235 students, the next year 1,178, and just put in this data directly from the table. And make sure that your numbers line up so they should match. And then we're going to go to Stat, and we're going to go to Calculate. We're going to calculate the linear regression. Calculate. And because we went to the catalog and we made sure that it shows the r's, we have our residual. And we're not going to worry about the r squared right now. So what I want you to write is the equation that we have on our calculator, which is y equals negative 35.13 x plus 1,208. We're just going to round it. And our r is equal to negative 0.96, which shows a strong negative correlation. And we can show that in our graph too by if we set our window up to fit this data. So our window is going to go from 0 to 10, counting by ones. So that's the years. And we do, let's say, 0 to 1,500 students, and we're going to count by hundreds. We can graph that, and it shows our lines, and then we can put our equation into the y equals. So clear that. Make sure this plot is on up here. So y equals this equation we have, negative 35.13, x is here, plus 1,208. And we graph it, and you can see that the line goes through those points.